All right. Hi, everyone. Thank you so much for joining our virtual demo. If you guys want to go ahead and turn your cameras on, that would be awesome. We would love to see some smiling faces and pretend a little bit more that we're actually together. Oh, look at that. Great. Thanks. Wave, everybody. Say hi to your friend next to you. Definitely social distance here. But thank you all for joining our BigRep demo. We've got our great reseller partner here, CAD Micro, with us as well. And we got a great agenda plan for you guys today. So first thing, a little housekeeping, since I'm sure we've all been using Zoom a lot. In the upper right-hand corner, there is a button that says speaker view. Depending on how you're looking at everyone now, you may be in the Brady Bunch view, I like to call it, with a whole bunch of little squares. You can switch it over to just see the speaker. This will help a lot when Chris is doing the demo, just so you can see it a lot larger there. We will also be taking questions throughout the demo. If you would like to ask them live, you can click on your name under the participant tab, and under more, it raises a little hand like that, or feel free to just chat them privately to me as well, and I will ask them to Chris or whoever I feel appropriate whenever I can sneak in there as well. But again, this is meant to be interactive. Since we can't be together in person, this is kind of the next best thing. So let's make the most of it. And so with that, I am going to turn it over to Frank.
Thanks, Abby, and welcome everybody. I wish we could have you to our office, our CAD Micro's office, but thank you for joining this virtual demo. I hope you get something good out of it. We promise not to be selling here today and not spend too much time chatting. Sue and I are going to introduce BigRep and CAD Micro a little bit, and then we're going to let you guys get right to Chris, Samnon, Maggie, and the system. So just in case you don't know BigRep at all, just give you a brief introduction. BigRep was founded in 2014. It's a Berlin-based company. It is focused 100% on large format thermoplastic extrusion systems. And we're proud to say that we are the leader in large format plastic printers. We have more than 500 printers. Around February this year, we passed the 500 mark, and that far exceeds everybody in this space. And it is not easy to figure out how to print a part that has 1 meter square, and it has to be on the plane, and you can do down to 0.1 millimeter layer heights, blah, 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 blah. And that comes with the good German engineering that BigRep was founded with. It is a German company founded in Berlin, as I mentioned, 2014. From the start, we thought we were going to be a global company. And we opened an office in the U.S. and in Asia. And our U.S. office is in Boston right now, or Maggie is in our New York office, and we are spread around the country like a good virtual high-tech company. Abby is in Michigan, and we have people in New Hampshire and in Massachusetts and New York. But our Asia office is Singapore, and of course our Europe office is in Berlin. One last thing about having a North American subsidiary for capital equipment, to be successful, you want to have your equipment, your spare parts, your filament, if you have filament, in our case, yes, filament, all located locally. So although we're selling a German product, we sell it from our Boston logistics team. And in your case, often because there is a border there between Canada and the US, we even store some things with CAD MicroSolutions, so that even save the time between the borders. But we don't have to ship most things from Germany. That's all I wanted to say today from BigRep standpoint. So let me turn it over to you, Sue, and introduce CAD Micro.
Hi, thanks, Frank. Excuse me. So I work for CAD MicroSolutions. I've been there for 3 years, specializing in additive manufacturing. I'm in a business development role, taking care of the eastern part of Canada. So a little bit about CAD Micro. We've been around since 1983, and we work with Canadian engineering and manufacturing professionals. So what we try to do is we try to help enable innovation and challenge the status quo. We are headquartered headquartered in Toronto, but we have 5 offices now across Canada. I work out of the Montreal office. Oui, je parle français. Si quelqu'un veut avoir une conversation après, il n'y a aucun problème. So we started off as a software reseller, and today we have diversified into software, 3D metrology, additive manufacturing, and VR, AR immersive technology. I always have to look at that because it's a little tongue twister. So we partnered up with BigRep in 2018 as we wanted a large format manufacturing solution. It was very complementary to the rest of the portfolio that we have. We believe in an application driven approach. And what that basically means is that we want to listen to what the customer needs. We want to hear what the requirements are, and then we want to match the right technology or solution. We want to make sure that the technology makes sense for their application and that there's a return on investment. That's it.
Thanks, Sue. And I think that's some of the things that you said match exactly why BigRep partnered with CAD MicroSolutions, because we also believe in really finding solutioning and solving needs. And we're not trying to sell a system, where we're trying to sell a solution and to solve a need. So that's something I think we have in common. CAD MicroSolutions is unique that you cover in the 3D printing world. You cover from design prototyping, functional prototyping, all the way into manufacturing, end-use parts. Some of our most exciting customers are in Canada, in your space, for end-use parts. Where do you see the biggest growth in Canada for, I'll be biased, large format 3D printing, but if you want to give the answer more broad, that's okay as well.
Okay, so what we've seen is mostly in tooling, so jigs and fixturing. The parts don't have to be big to print on a BigRep, but you can print more of them at the same time if you do it on a BigRep. Creative, so creativity, so unique and unconventional design challenges, you know, are we have some customers that do some pretty unique things, so that's where we see 3D printing. Aerospace, for prototyping, conformal travel carts for panels. What that basically means is anything that humans push, or custom, anything that needs to be done that's custom. Also in education, so for research support, for student interaction, as well as to just foster innovation, to bring new technology to a new era.
Yeah, one thing that BigRep helps from the education standpoint is the wide open machine and open materials. So really flexible from the slicer to the material type. A lot of research institutes, you know, do things that are not standard, and we support that. Other companies say, no, you can't use that on my machine, type of thing. Let's chat about applications once the demos are over, and I want to ask you some other questions. But for now, let's get to Wilmington. I'll switch it back to Abby, and then we'll see the demo.
All right, Chris, this is your 10-second warning. So before Chris gets started, just going to quick poll the audience. So I'm going to launch a poll here just to give Chris a little background into all of you that are joining us today. First question is just, are you currently 3D printing within your organization? Yes, not yet, but plan to start soon. No, with no plans, and unsure. Well, we have a very smart audience. It's looking like everyone is already 3D printing. Give them a couple more seconds here. We're at 94% so far.
Nice.
So
that's a lot of pressure, Chris. 94% of the people know what you're talking about.
Okay, it makes it easier for me personally.
Yeah, well, quick share the results here. So 90% of those on the call here said they're already 3D printing. One says they hope to start soon. One said no plans. So that's Chris's mission, is to convert that one. And nobody's unsure. So that's good that everybody knows what they're doing in their organization. So with that, I am going to stop talking and we will go live to Chris. And like I mentioned, we are live. Taking questions, so feel free to chat those to me or raise your hand, and once he gets done with his demo of the one, we'll have a chance to ask him some questions. It's all you, Chris.
All set. All right. Thank you, Abby. Thank you, Frank and Sue, for the introductions. My name is Chris Lee. I'm an application engineer / technician for BigRep. I'm accompanied by Amnon. He's the man behind the camera, who is our operations manager. The machine I have here is the BigRep 1. This is one of a few machines that I'll be going through in our office right outside of Boston. The office here serves as the main focal point for service, benchmark parts, and our print center, all for North America. So as Frank mentioned earlier, BigRep's been around for about 6 years, a little over 500 units globally. The flagship machine is our BigRep 1, with about 300 of those units being the machine you see here. This is sort of our claim to fame, our way into the market. This is our third iteration of the BigRep 1. We call it the BigRep 1 due to its build size of 1 meter XYZ, or 40 inches cubed. So the manufacturing and R&D, all that development is done in our Berlin office in Germany. We trust our German engineering. It takes a lot of it to be able to print at such a large scale for the amount of printing that we're running through. So, for example, the part that we have here was printed for about 6-7 days. We'll have another set starting right after this demo, and we'll continue on for at least the next month or so, printing these guys out. So, printing capabilities. We offer dual extrusion printing. They are retracting heads. So both extruders will not be printing at the same time. One will physically be higher or lower than the other. In this specific model, we use 2 materials. The first being a rubber-like material called TPU. BigRep's marketing is ProFlex. And then you can't see it now, but on the inside of this dome, there is a support material called ProHT. It's our non-toxic ABS. We're using that support material because of the angle at which the dome is printed. After a certain angle, there may be a slight risk of sagging or loss in quality. So with the ability of the dual extrusion and the more rigid material, support material, we can print it and then remove that support material after. So another big part. The gantry itself is belt driven by nanotech stepper motors. The positioning precision of those motors is about 100 microns in the X and Y, and then 20 microns in the Z. One thing I forgot to mention for the nozzles. So with the dual extrusion, we also have the ability to change out your nozzle size anywhere from 0.6 millimeters all the way up to 2.0. So depending on the size of the model, the speed that you want, and the resolution, if you had a 0.6 nozzle, you can print a little bit slower, but have really good looking parts. Or if you wanted a 2.0 nozzle, you can get a very large part, such as what you see here, done in a very short amount of time. The bed is 1/4 inch aluminum with a sheet of polyamide. We call it Kapton film sitting on the top. What that does is improve material adhesion to the bed and also distribute the temperature evenly so you're not getting any cold spots or warping or any shifts on the print. So a bit more on materials. As I mentioned, we have the TPU, we have ProHT. BigRep does offer a wide range of mid-grade, engineering grade materials, all plastics, so 2.85 millimeter filament, no pellets, no metals, and no powders. Outside of what BigRep offers for materials, which is already extensive, we offer an open material platform to where customers can take third-party alternatives, run them on the machine. The machine really doesn't care. It will run it regardless as long as it's within the same general temperature guidelines for the bed as well as the nozzle. So we trust our machines, we trust the engineering that went into it to be able to withstand whatever the customer wants to run. As Amnon does his work back. So when you are printing large parts, one thing to be aware of is running out of filament. So there are a couple different locations on the printer, one being in the extruder and then the other being above where the filament is loaded. We have filament out sensors. Once it recognizes a lack of filament, it will give the machine a pause command, pause immediately, and then allow the user to remove the old material, run in new material, and then continue the job, as is. And then if the MNOC comes over by the upright panel, we can just take a look at, the ease of use and the day-to-day working required for something like this. In terms of maintenance and upkeep, there really isn't much outside of keeping the bed clean and keeping the spindles well greased. You're not doing a whole lot. The machine's well built and meant to run 24/7, 365 in a wide variety of locations. So personally, I've installed BigRep ones anywhere from cubicles, low volume areas, high-end manufacturing facilities, as well as universities and anything in between. So I think it's a good overview for now. Any questions, anything that I missed?
Oh, yeah, you got lots of questions already. First one is on the bed leveling. Can you explain what features there?
Yep. So because the bed is so large, we needed a secondary process during initial setup to ensure that the bed is level and will stay level. So to the left of the extruders, we have an inductive sensor. That inductive sensor is just a fancy proximity sensor. It will go around the bed to 8 separate points, reading off readings, and then the technicians or the customers, they will adjust those readings to where they're all within a tolerance of plus or minus 0.02 millimeters. So very, very tight tolerances. It takes maybe 15, 20 minutes to get it perfectly level. We do this twice during installation. After that, after your first couple of prints, the bed settles in and there really is no need to adjust it afterwards. Em and I check it maybe every month or so just for standard procedures, but in most cases it's not needed.
All right, great. What is the nozzle sizes offered on the one, and then also what is the deposition rates for those, the output per minute or hour?
Nozzle sizes, it was the 0.6 millimeter, 1.0, and then 2.0. So if we're comparing a 2.0 versus a 0.6, the first thing is your resolution. When you're running the 0.6 nozzle, your layer height, so your resolution can get as low as 100 microns, so 0.1 millimeters. And then on the 2.0 nozzle, you can get upwards of 1.4 millimeter layer height. So either very rough and fast or low and slow to get the better looking parts. Generally, the overall throughput is scalable when you go from the 0.6 to the 1.0 to the 2.0. So if you have 0.1 layer height versus a 1.0, roughly it's 10 times as fast or so, depending on what you're doing.
All right, great. Another question we've got here is on the material. Can you only use one type of material?
So with our slicing program, which Maggie will get into later, you can do all sorts of combinations and features. So with the dual extrusion, you could do, if you wanted to do, I don't know, one part in multiple colors, you could have it switch partway through. If you wanted to do a batch of 12 items, 3 in the front are red, 4 in the back are blue, and if you want to switch them out after, you have that flexibility. If you wanted to do maybe an experiment of changing different resolutions partway through the job, you could have a 0.6 nozzle on one side, a 2.0 nozzle on the other side, have them print with different process settings, and then once they're all done, compare and contrast and figure out what you like best, and then have that run on the machine.
All right, another question, is the bed heated?
Yes, bed is heated to about 80 C for the BigRep one, and then the nozzles can get upwards of about 250 to 300 C.
Okay, and last one on the one is, what's the max weight you've printed on it?
Max weight, so Ann and I, we've together pulled off a giant mold. It was pretty much full XYZ volume, and it was about anywhere from 80 to 100 pounds. Probably took about 3 to 4 weeks. I believe it was just Pro HT, but with the application they were doing, it needed to be tough, needed to be rigid, so that's where all the weight came from.
Okay, and I lied. We've got one more question came in. Can it print PVB filaments?
PVB, I'm personally not familiar with that specific material. If it does have the same general requirements of what we run, so if it's under 80C for the bed, under 300C for the nozzle, and also doesn't require the enclosure, then we should have no issues with it and be able to print it as well as we can on the one.
Right. And we can follow up with you directly on that topic as well after. Okay, I will let Chris move on to the Pro. We've had a few questions about slicers and slicing, and just to give you a heads up, so Maggie, who's live in New York, she will give a demo on our blade software and talk a little bit more about slicing after Chris finishes with the printer. So stay tuned for that one. I didn't forget about you.
All right, all set?
Strength of materials, he's just testing it.
Yeah, seriously, it didn't break. We're good. So yeah, this is the BigRep Pro. This is kind of our second generation of the higher end version. So a couple of distinguishing features that I think make this, the leading edge of the FDM printers. So one being the new type of extrusion technology that we have, which is called MXT. And then we're also pairing with Bosch Rexroth and their high-end CNC control systems. With the new technology and the high-end motion control, we're able to get speeds and throughput that are second to none when it comes to our competitors. So a bit on MXT. With standard FDM printing, the limiting factor of how fast you can go is your thermal process. So you're pulling in your filament, you're waiting for it to melt, to heat up, and then you're able to print. What we're doing with MXT is taking out that thermal process, and that we're pre-melting a small pool of filament. So instead of waiting for the filament to melt, we always have something to pull from. And so now our limiting factor is the CNC control system. So with the MXT, we also offer a secondary option called the ACE extruder. The main difference right now is the MXT offers nylon for its material with more mid-grade engineering materials to come, whereas ACE has a wider range of materials similar to the BigRep 1 with now the ASA, ABS, carbon fiber filled, just because of the enclosure and some extra little hot ends and temperature requirements. So, same build size as the BigRep 1. You can see the part there that we have in there for scale that was printed a few days ago in our Pro HT on the ACE extruder. So with the engineering materials that we're having to run, we can run on the printer, there are a couple other options and features that we need. One being is the pre-processing, pre-drying of all of our filaments that require it. So things like water-soluble materials, ASA, I know TPUs are particularly temperamental with the atmosphere and moisture. So we have 2 chambers here and then 2 on the other side, just to make sure the material is in peak condition before it's printed. Next, we'll take you sort of under the hood of our machine, just to show you the high-end equipment that we have within the Pro. So comparing the BigRep 1 to the Pro, right now the 1 is about 1.1 to 1.2 times speed of your standard FDM industrial printer. The Pro compared to the 1 is about 2 to 3 times as fast. I think even now, with this being the first iteration of the Pro, we're still in the beginning stages of how fast we can actually go. With the Bosch Rexroth control system, there's so much data, so much more we can learn from our prints, to where we can have your inline manufacturing, high volume parts, understanding what's in spec, what's out of spec, and with the data that's collected, understanding your overall efficiency and your overall throughput that you're looking for on the year-to-year basis. So I think in some time we'll be getting at least 3 to 5 times as fast, with even more to come as we learn more and more about the system and the materials that we're running with it. So both the BigRep Pro and the 1, they do offer file upload via a secondary computer if you have it on Ethernet. And then with that, we also have the monitoring using the onboard camera if you just want to see what's going on during the prints. Temperature ranges for the Pro are a little bit different. The bed can now get upwards of 100 C, and the nozzles are about 350 C, just to accommodate for the higher grade engineering materials. The operator panel is Windows based. The BigRep 1 is actually Linux based. With the Pro, the MXT, and the control systems, Windows is just a little bit more user friendly for us and easier to do, remote updates and things like that. Any questions so far?
Oh, we've got a few questions. First one is, what's the approximate footprint of the Pro?
Yeah, so footprint, it's about 6.5 feet wide, maybe 8 feet in length, and then so I'm about 6 foot, so you can gauge it that way, maybe 6 feet tall. And there's a little pilot light in the back that adds another half foot.
And are the build plates removable?
Nope, build plates are stationary. So when it comes to part removal, as the bed is cooled, that will release most parts based on the materials. And then if you do use 3D printing adhesives like Magigoo, they are water-based. So you can just use a little spray bottle of water and then see it all dissolve and have the parts removed easily. So for something like this, the part that we had on earlier, it was in our Pro HT. We just waited until the bed was cool and it came off no problem. Obviously, we have the support material to remove and things like that, but very simple, very, very straightforward.
How long did it take to print that part you're holding there?
This guy here, because it was on the Ace, it's not as fast as the MXT. This guy took about 2 days.
And if it would have been on the MXT, any ballpark?
Under a day.
Under a day. And the one?
Yeah. The one, depending on your nozzle size, it could be anywhere from, I don't know, probably 18 hours on a 2.0 nozzle, and then upwards of 3 to 4 days if you did high resolution.
Okay, great. Another question is, what's the power requirement for the BigRep machines?
Yep. So the BigRep 1 is 208 to 240 volt using a 20 amp plug, and then the Pro is the same voltage but with a 30 amp plug.
All right. Do you have the ability to heat engineering grade filaments?
Yep. So right now, you pretty much have everything except your Ultim and Peak, your really high end stuff. So ABS, ASA, any of the carbon filled, glass filled, we all are in the range of that.
Great. Frank, I'm going to fire one at you that just came in. Are your machines CSA approved, which is a very relevant question for this audience?
Sure. So we have many BigRep 1s and G1s and G2s and the G2 that Chris is going to get to. And we do the GSA of those systems, the CSA approval on site at the moment. Very small changes that are made, so that's actually not a problem at all. And we have the Pro that Chris just went through, going through a revision in R&D right now, which will have some of the next ones that are produced with the CSA in the near term. And I hope before this whole year is up, all of our machines will ship with already pre-stamped CSA approval.
Great. One more question. Not sure which printer this one was for, but what's the diameter of the filament that feeds into the printers?
So the one, the Pro, and the G2, they all use the 2.85 millimeter diameter filament, or I think in most cases they say 3 mil on all of your local stores.
All right. That's all I got for this one. On to the baby of the family.
All right, yes, this is the little guy, the Studio G2. So we call it the G2 because there was a G1. The G1 is actually to my left here. The main difference is that the G2 has the full enclosure, the heated bed, so therefore the heated chamber. This has the same material options like the Pro. It does not have MXT, but it does have the upgraded gantry system compared to the G1. It's still dual extrusion. It's a single head, but there are 2 nozzles on the inside. And then with the engineering grade materials, we have all the standard bells and whistles, the heated filament chambers over here to dry out all of the old stuff, all-field moisture. The nanotech stepper motors, belt-driven. Bed is upwards of 100C, like the Pro. Your filament chamber, sorry, your print chamber will get anywhere from 40 to 50C. And then you have your onboard camera, all the standard safety features, out-of-filament sensors, exactly what you need to run the mid-grade engineering materials, nonstop on a machine like this. And then the build size. So it is still a baby, but it's still quite large. Build size is 1 meter long by a 1/2 meter wide and a 1/2 meter tall, or 40 by 20 by 20. And then just down here is where we feed all of our filament, which is where they're dried. Spool sizes that we sell range anywhere from 2 kilograms all the way up to 10 kilograms. But we do offer that open material platform. So I've seen spools as large as 25 kilograms used in our machine. And then like the one in the Pro, once you get it on Ethernet or Wi-Fi connection, you can do all of your monitoring. You can't start the jobs remotely. You can stop them. Just basic safety regulations that someone can't start it remotely.
What is
and then
the,
we do
oops,
have,
sorry.
yeah, there's one part off of the machine here. This is our PET CF, one of the mid-grade engine materials that we can run on the Pro and the Studio. So with the Studio and its smaller build size, by default, we have a 0.6 hardened steel nozzle, which will allow these mid-grade materials to be run, 6 months, 12 months at a time, depending on your usage. We do have customers that swap out the nozzles based on their needs, anywhere from 0.4 to 0.8, but that's just up to them and what they want to run.
Right now, I'll jump in and ask one question that came in. What's the temperature range for the base in the chamber?
Yep, the filament chamber, where these guys are heated, goes up to 50C, with the bed going up to 100C. That print chamber, like I said, goes up to about 40 to 50C ambient. And then if it does exceed that temperature, there are fans on the upper portion of the printer to release any of that hot air so it stays at the correct temperature.
This one says, is there an upgrade for a bigger nozzle, or what's the biggest nozzle that the G2 can handle?
Yeah, so BigRep officially sells 0.6 nozzles, but I've seen customers use 1.0, and I believe it was a 1.2 nozzle. If you wanted to do a 2.0 nozzle, you certainly could. I just haven't personally.
All right, we got any more questions for Chris? Maybe Chris, talk about the power requirements also on the G2.
Yep, G2, same power requirements as the BigRep 1, 208, 240 volts with a 20 amp plug.
All right, great. Any other questions for Chris before we go to Maggie?
Yeah, so actually we'll do one other thing. So normally with our trade shows, we'll have some of these really cool parts out in front of you guys. You'll walk by, you'll see this nice little F1 car, come talk to us, exchange business cards, things like that. This is the best we got for now. Me talking to you through a screen, but I still think there are pretty amazing parts that show off the full range of the BigRep machine. So this piece here was printed in 3 separate parts, right, left, and center, with a little bit of post-processing, sand, prime, and a little bit of paint. You can get this really high-end looking part. And that just catches everyone's eye. I love this part. And then up on the level here, some of our higher grade materials. So this is our ASA. And then this is our nylon PA6.66. This one here shows off a little bit more of the post-processing. So at its core, it is Pro HT. And then on the outside, it was post-processed nickel plating. So if you wanted a lightweight part that wants a little bit more, chemical resistance, if you're feeding a annoying liquid through, this will be perfect for what you're looking for. And then our airless tire here, this actually came off of our Nera bike, our fully 3D printed outside of the battery and electronics motorcycle that we have a lot of videos on. Our designer Marco, he was riding this around the streets of Berlin The outer edge, the tire, is our TPU material called ProFlex, so that gives you your smooth ride. And then the rim in the center is our Pro HT to make sure that it's structurally sound and it's not going to break while you're riding it, going 40 miles an hour down the hill. I highly suggest looking into the Nair bike and all of the other projects that we've done so far with the BigRep machines.
Hey, Chris, show the voice part, because it's not as exciting as the Nair or the Formula One, but in reality of 3D printing, it's even more exciting.
Yeah. Like I said, yeah, it doesn't catch your eye, but once you hear the story, it's a lot to take in. So with Voice Technologies, they have these 5G cell towers all throughout New York City. Initially, they bought the 3D printers more for prototyping, just to understand how to change their designs more fit. Their CEO, their president, realized with the throughput they were getting with the studio, I believe it was the G1, they could use these for end-use parts, and that's what they've been doing for the past 6 months to a year. These guys are, I believe, air vents that go on those towers, either PLA, Pro HT, I believe this is Pro HT. And these are sitting in their towers right now, being used, and with the material properties that BigRep offers, no need to replace them, or there is no worry for them degrading in the field. And then because of the experience they have with this part here, they do also have the BigRep Pro, just to improve their overall manufacturing capability.
All right, great. Well, if no more questions for Chris, and he's not going anywhere, so in case you think of another one, we can always jump in and ask him later. While Maggie gets set up here, I am just going to launch one more poll question here. So we're just curious, since again, we can't ask you this face-to-face, what's your biggest challenge, since we realize that almost all of you are already printing? Where do you see your biggest challenges with additive materials, speed, size, budget? Not really sure. All of the above. All the answers are coming in. It's a little all over the board here, which is good. Lots of challenges we can help you solve right now. Budget and size are leading the way. I'll give them one more second here. All right, let me quick share these results here. This will give Frank and Sue a little fuel to discuss later too. But biggest challenge is budget is the #1 challenge people are struggling with right now. And #2, which is a great answer for us, Frank, probably glad to see this, is size. Our strength we've got here. So thank you for answering that. And with that, I will stop sharing this and we will go to Maggie.
Great. Hi, everyone. So I am coming to you from Brooklyn, New York today, and I'm just going to do a really brief overview of Blade, our new slicing software. BigRep Blade is an in-house slicing software that we've been working on for over a year now. The reason we moved away from third-party slicing programs was because we really wanted to get the most accurate, optimal program for our clients to use for large format printing and for the BigRep machines particularly. As you can see here, the layout of BigRep Blade does look a bit like Cura, so if you're familiar with that slicing program, this probably will look familiar. As you can see here, I have our BigRep Studio G2 pulled up, but if you click up over here, you'll see all of our printer options. So they're all within one software, one format. You can do dual extrusion printing, so you have your two print heads here. And then under this is where you will see all of our possible materials. So the great part is that we do provide presets for you. So if you're not super familiar with 3D printing or with slicing, which it seems like most people on this call are, people in our R&D team and our materials team and software have all contributed to this program. So the settings that we've laid out for you, we're really comfortable sharing and feel will give you a successful print. But if you are more familiar, and as you'll know with Cura a bit, there are a lot of options to tweak. So everything from the shell to the infill, to your support structure, you can kind of go in there and see the different options that you're able to play around with. Over here also, we provide you with numerous different layer heights and a default versus a visual setting. So essentially a balance between default would be a good print and a bit faster. Visual would be sort of the best option and a bit slower. So it kind of depends on what you want. So not only do we provide you with the settings for all the materials, different nozzle sizes and machines, but we also give all the settings for the different layer heights for you. All you need in this program is a clean STL to bring in. As you see here, I'm using the manifold that Chris was showing you a little bit earlier. And I'm right now in the prepare view, but I'm going to switch over now to the preview. Normally you would hit slice down here. I did that before I joined on the call to make things a bit faster. The other great part of Blade is that it gives a really accurate print time. And in terms of material, it tells you exactly how much you need for your part. It also provides with a really great preview of what your part is going to look like once it's printed on the bed. I'm currently now, there's numerous different color schemes and view types that you can choose. This one happens to be my favorite. This is the line type view, so it assigns a color to all the different line types. Red being the outer surface, blue being support structure, dark blue being dense support. You know, the light blue down here is the brim, and then yellow is the top surface. And then you can actually go through your part sort of step by step to see how it's actually even going to build up on the machine, which I also find to be really helpful. You can kind of see if there's anything strange anywhere within your model. And then as you'll see over here in the bottom right-hand corner is where the output information is. So right now I have it at a 0.5 layer height in the studio, which is actually the highest layer height you can go with the 0.6 nozzle that we recommend. So it's a pretty quick print. It's 13 hours for this part. And as well, it gives you the amount of material you're using here, which is, 0.5 kilograms. And then if you want to break that info down even further, so if you want to say, okay, I want to print this even faster, you can actually hover over this info button and it's going to give you a time estimation for each different element of your part. So as you can see, infill only takes 3% of the time, inner wall, outer wall, support takes this amount of time. So then you can break it down even further and optimize your print even more. And then the last thing I'll mention is two really special things about Blade actually are that it has automated batch printing. So as you can see, when I go up here to the extensions tab, you can arrange models for mix mode. So that means printing models one by one, but numerous models at a time. Or you can automate build plate completely. So it means that you can fill the build plate completely. It'll do it for you in a really intelligent way. So it makes batch printing really easy if you do end up using this for a manufactured and used part. And the other aspect is the auto orientation. So this will actually take the part once you bring it into the program and orient it in a way that optimizes it for the fastest printing. And I think that's about it for me. The other thing which I think Chris already mentioned is that if you have your internet connected directly to your machine, you can actually save to file and upload from your computer. Otherwise, you would just save to file as a G-code file, put it on a USB stick, and bring it over to your computer manually.
All right, we do have a few questions for you.
Sure.
Okay, so first one, I'm hearing some echo, I apologize for that. Do you have to use Blade?
You only have to use Blade for the Pro machine due to the MXT extrusion technology. For the Studio G1, G2, or the One machine, you are allowed to use third-party software. Blade is free though, and we do suggest or recommend that you use it as it's the one that we've sort of optimized the most. But we do still offer factory files for Simplify 3D if that's something you're more comfortable with, or any other program. We're happy to work with you to make anything work.
All right, another question. Do you have a variable layer height?
Yes, that is an option. So I'm assuming you mean the variable layer height in terms of the machine assessing in terms of detail what the layer height should be. And yes, that is an option. I believe that you will find that under special modes here.
Great. Another question, not having sliced any parts in this size range, are there processing constraints or issues with slicing?
No, I don't think so. But our team is here to help you along the way. I do find that since releasing Blade and not using third-party software, it's really attuned to what needs to happen. Our team has put in a lot of work and effort to sort of figure out the best possible settings. But obviously, there's always going to be parts that are a little bit more complicated or that might need a little bit more specific attention. But that's what we're here for. So we're here to help you, learn. We provide tutorials, and upon purchase, you'll receive, a lot of teaching along the way.
Can you monitor the prints remotely?
Yes, so that you do have to be connected via the Ethernet to do it, but we do provide an option to get a camera for your machine. As I'm not sure if you saw on the Pro, but there's already a camera installed. On the One, you can buy it as a separate entity. And then you actually can monitor from your computer or your phone how the print is going.
Great. And last question here is, what's the typical upload time for a part like this manifold?
Really quick. So slicing the actual part takes, 20 to 30 seconds. Obviously, the larger, more complex the parts are, it takes a little bit longer to generate that G-code. Putting the G-code onto the computer is always really quick. I mean, I think, once I printed a sofa that basically filled up the entire one platform. And that part was quite complex mesh-wise, and maybe that took up to a minute. But generally, parts like this will just take a few seconds to upload.
All right, great. All right, well, if there are no more questions here for Maggie, I'm going to launch the last poll here. Just curious, as we go into the last part with Frank and Sue, in terms of applications, are you currently printing prototyping, tooling, patterns, molds, castings, end-use parts, or not printing? So again, check as many as you want. So kind of spur the conversation for this last 10 minutes of our demo. Answers are coming in. Right now, it's looking pretty heavy on the prototyping side. We'll give everybody a few more seconds. I really appreciate all this participation. Again, I would love to ask you this question in person to each of you, but since we can't, I'm going with this method. So here's kind of the results. So the most used application is prototyping for you guys, and then actually the second use is end use parts, which is great to hear. And then tooling is next, and patterns and molds came in at third there. So with that, let's turn it over to the last part here. Oh, there's Chris riding the bike, if you can see that in the background. But I will let Frank and Sue take it from here.
You're always trying to steal the show there, Chris. How can you pay attention to me when he's entertaining us around the office? Anyway, thank you. Thank you for joining the demo. I think these guys do a great job, and Sue and I couldn't do a better job selling you, but the system sells itself. Chris did a great job. A couple of things that came to mind during the demo. There was the question of size. So I always like to answer the question. We have 1 meter cubed systems. The little guy, we call it, is 1 meter by a half a meter. You say, I don't need that big of a printer. And my answer is, you just need a large printer that's bigger than what you can get alternatively. And a typical printer is, desktop printer is about 200 millimeters at most. And a lot of parts are exceeding 200 millimeters, or one dimension is exceeding 200 millimeters. And to have the flexibility, the freedom to print on a G2 or a 1 or a Pro, but even a G2 with 1 meter in one direction, then you can lay it out the way you want. You can lay out the strongest dimension so that it's in the X or the Y, for example, or you could lay out with one direction where you have finer features, and that can be in the up-facing direction. So there's so much more flexibility as well. During a lot of this COVID thing, a lot of our customers are printing some PPE, some shields. I know that CAD MicroSolutions printed some shields. And if you were printing one off at a time on a desktop printer, you just have to be there when it ends, and you never are that efficient, and you're not going to be there all through the night. But if you could set up a printer with 50 parts on it and then just push print and let it print overnight, it's much more efficient. So it's good for large parts, it's good for orientating parts, and it's good for a lot of small parts. So our customers are doing a wide variety. So let me now turn it to you, Sue. What size parts do you see coming to you mostly, or where do you see the most interesting kind of parts or designs in large format parts for BigRep?
That's an interesting question. So the large format is usually the #1 reason why people will gravitate towards BigRep. While there are a lot of great adhesives and ways of, you know, creatively putting parts together, this definitely saves a lot of time. For the smaller parts, as you mentioned, putting multiples on the bed, what I think is really advantageous also with BigRep materials is that you have the large spools, so you're not constantly changing rolls. You just let the machine run, and yeah. So I have seen larger parts. Recently, somebody came to us with a part that was almost was 470, I think, millimeters. So that was an interesting part, and it was one that they wanted to print in one piece, and your team was successfully able to print a really nice benchmarking sample. So yeah, that was a nice part.
Yeah, that one piece part reminds me always of the Steelcase benchmark, which we have case studies on our website, because they used to use desktops in printing their industrial furniture. They're leaders in industrial furniture, and they were printing it in multiple pieces and pinning it together. It took a lot of time in CAD, and they're finding that their functionality wasn't properly representing that furniture. So they bought a BigRep printer. It solved a lot of their problems. They were producing faster and better furniture because of it. And then they put BigRep printers in their design offices all over the world. And you know, that's just makes it a lot easier if you have a large part. The other thing that comes to mind is that, you know, you have the flexibility of all of the materials, and so that's from a price standpoint. We're very competitive priced materials, but if our materials don't fit your needs, and we're open so that we allow our materials to compete on the open market. We don't force you, as both Chris and Maggie mentioned, we don't force you to use our materials, but we want you to use ours, and you have the benefit that we've painstakingly created programs for each of our materials and each resolution. So in most cases, it's plug and play, you push print, but the Blade software has enough flexibility for you to set up other materials. So you can do materials if you needed different mechanical properties or other properties. The other thing is that because we know large, you mentioned, Sue, the large spools, 8 kilos spools at one time, you can set up a part that uses both spools. So that's 16 kilograms of material that you have access to. We have the ability to have it pause at the printer if it runs out of material, and you don't ruin a print. These are just little things that, you know, BigRep knows. After you've invested days of a print, you don't want it to crash because you miscalculated the end of that spool. Just little things, for example. The other thing is to have the flexibility of resolution. So we go to 0.6 nozzle up to 2-point nozzle. Chris mentioned that. 0.1 millimeter layer height, 1.4 millimeter layer height, because sometimes you want fine features, but sometimes you just can't afford the time. So we understand that because we're into large format printing, and customers balance between resolution and speed all the time.
Right. One thing that you touched on that was really interesting is that, you know, they start with one machine and then they start going with it, and then they just continue. So we have customers who have purchased one, started with one, and have multiple, we'll call them fleets of BigRep printers. So, you know, just because they need the large format and all of that. So
yes, that's really interesting, Sue, because two things. One is, as more than 50% of your customers say they're thinking about printing for end-use parts. That's a natural extension. The more that you print, the more that you need. But the other reason that people buy multiple systems is so many other applications that customers find to use the printer that they didn't think of when they brought it in-house. It could be they bought it for prototyping, but they find that manufacturing wants it for jigs and fixtures. Or like Boyce, they bought it for prototyping and they used it for end-use parts because it met their mechanical and accuracy characteristics of an end-use part. And they didn't have to mill the aluminum and lose like 90% of that part. It was a vent, so it was most of it was going to get milled away. So there's a lot of waste in programming, and they just went to there and therefore expanded. But others, really interesting, is things you would never think about. You wanted to, you know, vent some other machine, so you create some custom venting or some cover. One of my favorite parts of the Ford jigs and fixture case study is that they have this rubber TPU piece that they put over cement blocks on their factory floor because tires were rubbing up against it and creating marks on the tires, and customers were complaining that the brand new Ford had a scratch in the tire and it was causing pain and cost. Anyway, there's so many applications for large format printers. One thing I would say about the G2, it's large in 1 meter by half a meter, but it's pretty small footprint. It's really quiet. So it can be in an office environment right next to a cubicle or an open concept environment and not bother the people that are sitting at the desk. So it's pretty flexible and interesting, the flexibility of how to use it. So what else is on your mind today regarding your customers?
Just that, you know, it's important to consider when you're considering 3D printing that it's the competitive advantage. Mm-hmm. So when I say that, I mean the secrets, your product development, customization, reducing risk. So by prototyping, testing in advance, savings, you only use what you need. You talked about additive, adding rather than subtracting, and time for faster iterations and faster time to market. So that's been one of the big benefits that a lot of our customers have seen when they've adopted 3D printing, is that they're able to increase their business because they can do more product in a shorter period of time.
Right, perfect. And one of the things that we have the expertise, and CAD MicroSolutions clearly has the expertise as well, it's to help customers integrate additive in areas maybe that they don't have that expertise. And it's not often prototyping. Normally you design it and you print it, it's okay. But if you want to integrate it on the manufacturing floor for jigs and fixtures or trays, custom trays, we have this pretty cool solution, which is a configurator that allows you to create jigs and fixtures without having to know CAD. And a lot of the manufacturing engineers don't know CAD. So we're here to help our customers, both BigRep and CAD MicroSolutions, implement jigs and fixtures on your floor. We have a business unit called Engineering Solutions, and they help our customers figure out the best way to implement BigRep printers. So you don't need an expert in-house to get that done. And that's true in end-use parts as well. The prototype maybe always doesn't have to have all the efficiencies of manufacturing, but we have customers, as you mentioned earlier, Sue, that are using BigRep printers for end-use part. Now you want to fine-tune the process, either in surface finish or removal of support, and Maggie hit on some of that earlier, but if you can take out a few minutes or a few kilos of support, then, you know, that's time is money in the end-use part more than anything. And we're here to help your customers. And last thing I want to say, because I didn't get to it, but I noticed that some customers are doing sand casting. Some of your customers that signed up today are doing sand casting, and we have that expertise. In BigRep, we have several customers. We have the Time Bridge case study, you could look into it, and JC Steely case study. So those are two applications that are doing very traditional industries, but we helped bring on BigRep additive into their more traditional industry. So, you know, we're here to help, and I know you guys have the expertise in your organization as well. So together, we're here to help your customers.
All right. Well, it looks like we are pretty much out of time. So I think with that, we'll get ready here to wrap it up. But first, I'd like to thank Chris in our Boston office and Maggie in New York and Amnon for his awesome, steady hands behind the camera. Thanks, Sue in Canada and Frank in Boston, and I'm in Michigan. But it was really great to spend this hour with you all and to show you the printers. Got a really nice comment just now that said voting for the 3D printing webinar of the year. I'll take that as a good compliment. So,
Wait, Abby, is your mother on the line?
she is. Yes. Thanks, Mom. No, just kidding. That was from somebody that was not from my mom, but we really appreciate it. And we really like to see you guys all soon. So following here, I'm going to offer up the services of my amazing team here to do a free print analysis with Sue's team as well. So if you've got a challenge, a lot of you said size, they're our team at Challenge. They're amazing. And so they can definitely help you out on that to show you really the capabilities of BigRep printing. And with that, I will be sending out a recording of this. So if you'd like to watch it again, show your boss, buy a printer tomorrow, all the good things there. But with that, I'd like to thank you all again and stay safe, stay healthy, and go BigRep. Thanks, everyone.
Thanks.